All right, we got section 3.3. This is a pretty important section. This is where we're going to start writing the equations of these functions rather than graphing them. So we're going to need to use all the things that we learned in sections 3.1 and 3.2 to achieve this. The first one kind of walks us through here by giving us some fill-in-the-blank questions, but these are the types of things that we need to ask ourselves on the other questions which don't have the fill-in-the-blank parts. Also, we want to note that there's a big difference between how they ask the question. If they say write an equation versus write the equation, that's a big difference. An equation is a lot easier. Basically, it means when we're finding our a value, our number, our leading coefficient, it just has to be the correct sign, basically, a positive number or a negative number. The equation means I need to know exactly what that number is. Is it positive 2 or is it positive 7? Okay, so the and equations are a little bit easier. Right, the equation requires a little bit more work, but we'll get to that in a minute. Let's start with number 1. All right, so we have how many real zeros for this function? Okay, so here's the graph. We want to write the equation of this graph. Well, remember, zeros or roots, those are just another word for our answers, which also represents our x-intercepts. So when they ask how many real zeros we have, that's just kind of asking how many unique x-intercepts do we have. So let's see, we got 1, 2, 3, 4, 5 times we cross the x-axis. So then we have 5 real zeros. Okay, and that's the main part of our equation is these x-intercepts. That's going to give us the bulk of our equation. Okay. Let's see, they are all, it kind of says here singles. Another way to say is they all pass through. Because right at each of our x-intercepts, our line is either going to, our curve I should say, our function, is either going to pass through the x-intercept or it might bounce off of it. Okay, and that's a big difference there. But since they're all pass through, they're all singles, therefore it must be a what degree polynomial? Well, remember, we pass through when it's an odd multiplicity. Now, yeah, technically this could be a first degree root or a third degree or 17th degree or 1001st degree, okay? But if it's odd, we're just going to call it first degree. If it bounces and it's even, we're going to call it second degree, even though that doesn't have to be the case. We want to keep it as simple as possible. So pass through, we're going to say it's a first degree multiplicity of 1. If it bounces, we're going to say it's second degree with a multiplicity of 2. So we're going to say it passes through, so 1, 2, 3, 4, 5. It means it has to be a fifth degree polynomial. Okay? Which, yeah, it's odd. High to low is our end behavior, so then that's good. Which is the next part. The end behavior is high to low. So it's all making sense here. And then the a value must be what? Okay, well, if it's high to low, then what type of a value am I going to have? So whenever it's odd, whether it's fifth or whatever, think like a line. If my line goes high to low, so it goes from here to here, well, that's a negative slope, right? It's going downhill, so then that must be negative for the leading coefficient to give us that end behavior of high to low. Okay? And then now that we have all these pieces, well, now I can write my equation. It's going to be kind of long, so I'm going to write it up here where we have a fair amount of space. Could probably fit it down here, but let's go where we know we have plenty of space. All right, so my function, I can put y equals or f of x equals, doesn't matter. I'm just going to go ahead and use f of x. F of x equals, and then, well, it's going to be some a value, and it's got to be some negative number. So it could be -1, or I could just put a negative, or I could put -2 or negative any number. It does not matter which number you use. That's the nice thing about and, is it just has to be negative. And then what's the rest of my equation going to have in it? Well, how do I get an x-intercept at -8? What factor do I have to have that gives me an x-intercept at -8? Well, x plus 8. Because here when x is -8, I get a 0. Okay, I get an intercept. Next, to get a x-intercept at -4, what factor do I have to have? Well, x plus 4. Then to get a x-intercept at +3, I got to have x minus 3 as a factor. To get an x-intercept at +5, I got to have x minus 5 as a factor. And finally, to get an x-intercept at x equals +7, I got to have x minus 7 as a factor. And then there is my function. So yeah, it's a big, long mess, but it really wasn't that hard. Most of this stuff just came from our x-intercepts. Okay, and usually that's something that they're going to give you. In fact, they pretty much have to give that to you. Okay, one way or another. Sometimes they'll show you on the graph where they're at. Sometimes they'll write it in a different way. Okay, and then that's the first one. And again, the only thing we could change if we want to is instead of a -2, it could be negative some other number. Okay, do we have to multiply this thing out? You could, it'd still be the correct equation, but why bother? This is fine, we're done. Okay, so that's number one. All right, number two, similar question. We want to write the equation and sketch the graph of the cubic function. So remember, cubic is to the third power with zeros at -5, 2, and 4. Now, since we know it's a cubic function and they gave us these three intercepts, we know they all have to be to the first power. Because if any of those were higher, second power, third power, whatever, it wouldn't be a cubic function, it'd be too big. Okay, so this one's nice. We know they're each to the first power, which means I know my intercepts are going to pass through. All right, let's draw these first. So we got zeros at -5. So put a point there. +2. And +4. Okay. And then also we have a y-intercept at -8, so that's going to be somewhere down here, some negative number. Okay. And then is that exactly 0, -8? Well, it is as long as I label it. So then we'll call that 0, -8. Okay. Now, we could draw this thing before we worry about the function. I have enough to draw it now. I know that since this is a cubic function and I have these three intercepts, well, then they all have to pass through because they all have to have a multiplicity of 1. So then I know I can start here at my y-intercept. I know it's going to come up here and pass through. It's going to come back down and pass through there. So it's going to look something like that. So it's going to finish low. And then coming this way, it's got to eventually come up and hit our other x-intercept there. And then so that means it would start high. So then high to low is my end behavior. And again, it has to be that because I know I have this intercept, this y-intercept, and these three x-intercepts. And I know the x-intercepts all have to be pass through. They all have to have a multiplicity of 1. So it's going to look something about like that. Okay, definitely high to low with these 4 intercepts. Okay. All right, now we want to write our function. Okay, so what's our function going to look like? Well, it's going to be f of x equals or y equals whatever. We'll use y this time. It's going to be y equals some a value, that's what we want to find out, times, and then what are my factors going to be? Well, if I have an intercept at -5, I got to have a factor of x plus 5. And I know it's to the first power. If I have an intercept at +2, I know I got to have a factor of x minus 2 and a factor of x minus 4 for that last one. Oops, x minus 4. Okay, and again, they're all to the first power, so I leave it like that. And that's pretty much my equation. What's the last thing we got to find? Our a value. Okay, now this is nothing really new. We find the a value just like we find the a value in our other units. We're going to take a point that they give us and stick in the x and y values for that point. My x is going to go in these 3 spots. My y value is going to go there. And then what's the only other point they gave us? The x-intercept. Now, it's not always going to be the x-intercept. It just can't, the y-intercept. They're not always going to give us a y-intercept. It might be some random point on our function. We just can't use the x-intercepts because if we do, if I stick in 4, for example, well, that's 0, so then the whole right side of the equation becomes 0. It just doesn't work. Okay? So I want to stick in x is 0 and y is -8. So then that gives us -8 equals some a value times, and let's do a little mental math. 0 plus 5 is 5, 0 minus 2 is -2, and 0 minus 4 is -4. Okay? All right, then we just got to simplify and solve for a. So let's see. It doesn't matter which ones we do. -4 times -2 is +8, times 5 is 40. So since the right side, well, let's go ahead and show our work here. So we get -8 equals 40 times a. And if we divide both sides by 40, then these cancel and I get a by itself. So we get a equals, and then -8 over 40 reduces to 1/5. Okay, so then now I've got my a value. Now I can plug that in up here, and I'll have my whole equation. Let's put it right here where we have a little bit of space. So we're going to get y equals -1/5 times all my factors, x plus 5, x minus 2, and x minus 4. And then that is my equation. Okay, and then just always check. We got an a value of -1/5. So let's see, this is a cubic function with a negative leading coefficient, so that should be high to low. Is it high to low? Yeah, looks good. So nice quick little check there. All right, so that is number 2. So you can see when it says write the equation, it's going to be a little bit more work because we have to find the exact a value. If it said write an equation, Well, knowing it's high to low, we could just put any negative number in front. But because it said the equation, well, we got to figure out, well, what is that actual a value? Okay. So to find that a value, you just need one other point that's not an x-intercept on your graph, and you can use those x and y values to solve. All right, next one. Write the equation and sketch the graph of the quartic function. So quartic means 4. Okay, so it's a 4th degree polynomial where f of -6 equals f of -1 equals f of 3 equals f of 4 equals 0. Okay, that's a lot of equal signs. Let's look at just the end of this thing. F of 4 equals 0. Okay, so what does that mean? What does f of 4 equals 0 mean? Well, it means in my function, when I stick in x is 4, I get y is 0. So 4 comma 0 is a point. Well, f of 3 is the same as f of 4, which is 0. So f of 3 equals 0. So I get the point 3 comma 0, -1 comma 0, and -6 comma 0 as well. So they are giving me my 4 x-intercepts just a little bit differently than they gave it to us on the previous problems. All right, so let's plot those. -6 comma 0, -1 comma 0, 3 comma 0, and 4 comma 0. All right, so then they give us those x-intercepts, and they also said that f of 2 equals 144. So when x is 2, y is 144, so it's going to be some positive number up here. Okay, and again, is that actually 144? Well, sure, if I label it, it sure is. 2 comma 144. That looks good. Okay, now since it's a quartic function, and I have these 4 points, these 4 x-intercepts, can any of them be raised to a power higher than 1? Well, no, because if, let's say this was squared and this is to the first, to the first, to the first, that'd be 1, 2, 3, 4, 5. That'd be a 5th degree polynomial. That's too big. So since it's quartic and we have 4 x-intercepts, they all have to be raised to the first power, which means they're all going to pass through. Okay, so then I can start at my point up here and say, okay, it's going to go from here down to this x-intercept. I know it's going to pass through. It's got to come back up and also pass through that one. So it's going to finish high. And then, let's see, it's going to come back down, hit this x-intercept, pass through. Got to pass through that last x-intercept as well. So then it's going to start high as well. So this one's high to high. Okay, so quartic is even, so it should either be high to high or low to low. So yeah, high to high looks good. And then that also tells us what about our leading coefficient. Is it going to be positive or negative if it's opening up? Positive. So then good, we know a few things about our equation. All right, so let's start to write our function. What do we know is going to be in our equation? Well, it's got to have y equals or f of x equals. And then let's see, it's going to be some a value, and it's going to be some positive number times, and then what are all my factors going to be? So to have an x-intercept at -6, I got to have x plus 6 as a factor. We know this is the first power because it passes through. I got to have x plus 1 to get -1 as an x-intercept. I got to have x minus 3 and x minus 4 to get these two values as well. Okay, next I want to solve for my a value. Okay, well then I need to take a point on my graph that's not an x-intercept, so the only one we have is this one up here. And then I want to stick in x is 2, y is 144, and then solve for a. And then once I have a, I can stick it in here, and I'll have my equation. Okay, so let's see, y is 144, when x is 2, so then we're going to have some a value times, let's do a little mental math to save some space. 2 plus 6 is 8. 2 plus 1 is 3. 2 minus 3 is -1. And then 2 minus 4 is -2. All right, so let's see. 8 times 3 is 24. Times -1 is -24. Times -2 is -48. So 144 equals -48. Sorry, positive 48. A. And then if we divide both sides by 48, then we get a equals 3. All right, so then we want to plug that in up here, and we get y equals positive 3, which is good because it's high to high, so we know it should be a positive number, times these 4 factors. X plus 6, x plus 1, x minus 3, and x minus 4. Okay? All right, and then that is our equation. Okay? And again, this is our equation in factored form, but that's fine. Why bother doing something different? Why bother multiplying that out? That's too much work. This works. Okay? All right, and then one more for this page. All right, write the equation and sketch the graph of the cubic function with x-intercepts at 0, 4, and -5. So again, it's cubic with 3 x-intercepts. I know they're all going to be to the first power already. So let's see, 0, 4, and -5. The graph also passes through the point -3, comma 14. So I'm going to have some point somewhere up here. We're going to call that -3, comma 14. Okay. And again, since we know they're all passed through, then it's going to come down and pass through this point here. So it's going to go from low to, let's see, pass through. It's going to be low to high, which it's cubic, so it should either be low to high or high to low, so it looks good so far. Low to high also means it's going to have a positive a value. Okay, and then how do we find that a value? Well, what's my equation going to look like? Well, it's going to be y equals some a value times what factors? So let's see. To get a factor, an intercept of -5, I need x plus 5 as a factor. Let's see, to get an intercept at 0, I need, you could just say x, or if you put x minus 0, that's fine, or x plus 0, that's also fine. Okay, just a regular old x would be perfectly fine there though. And then to get an intercept at +4, we need x minus 4. Okay. All right, so now to solve for a, I want to use this point, stick in x is -3 and y is 14, and then solve for a. So we get 14 equals a times, so if we stick in -3, we're going to get 2, -3, and -7. Okay, and then if we multiply that out, let's see, -7 times -3 is +21, times 2 is 42. So we get 14 equals 42a, and then divide both sides by 3. I'm sorry, by 42, I'm thinking ahead. There's going to be a 3 involved there. We get 1/3. So a equals 1/3. And now we can stick that in here, and we'll have our equation. So it's going to be y equals 1/3 times x plus 5 times x, which if you want to, you can put it right in front. That's where we normally put the monomial. So it'll be 1/3 x times x plus 5 times x minus 4. If the x is somewhere in the middle or at the end, that does not matter. If I'm multiplying these 4 things, 1/3 and x plus 5 and x minus 4, the order doesn't matter. I'm just writing it how it's normally shown. Okay, but it doesn't matter the order. All right, and then that's the first page.